Hey, good day everybody, and in this video we'll be talking about areas. Now you can see here that we have the areas of some shapes, and these are the areas that essentially we're going to need to know. And we have some formulas here, and we'll take a look at these formulas. Now the formulas are pretty easy, right? You can see with perimeter we had to add all of the sides, but with area we just have to take one side and multiply it by the other side. Yeah, so in this case, this rectangle here, this long side is B and the short side is H. So the area of the rectangle is B multiplied by H. So it's just side multiplied by side. Yeah, and of course this will go for a square as well. So if I had a square, and that doesn't look too much like a square, but if this was S and this was S, then the area would just be S multiplied by S, right? S times S. So to find, once we're dealing with right angles, you just multiply the one side multiplied by the other side, and you'll get the area of that shape, that quadrilateral, right? Now the area of a triangle, and we'll have to talk about this a little bit more, because what you have here is the length of this side, which is B. Yeah, they have it as B, and you multiply it by not the long length, but the actual height. And notice this is the perpendicular height. This is a right angle here, so you have to multiply it by the perpendicular height. So the area is actually a half the base times the perpendicular height. Yeah. Now the area of a triangle is just basically if I had a square, and let's just say that this was B and this was H, right? So therefore the area of the square would just simply be B times H, right? Now remember, a triangle is if I take this and I cut it in half, and now I'm only dealing with this area over here. So that's half of the square. So that means that it'll be a half B times H. Yeah. So the area of a triangle is equal to a half B times H, or a half of one side times the height. And remember, this height depends on that right angle, so it must be the perpendicular height and not the height of this side over here. Usually the perpendicular height is given to you, and you could see here that this perpendicular height business is true for parallelograms as well, where I'll take this A and I'll multiply it by this height here, which is B, which is a perpendicular height. It's not necessarily the length of this side here, no, it's the perpendicular height. So this height here, which is perpendicular, B, is the area of the parallelogram. Now you will have to know area of the trapezium, and you can see here that these are also dealing with perpendicular heights. So it's a half of the sum of the parallel sides. So you notice that this side here is B and this side here is A. A and B are the parallel opposite sides of a trapezium. Yeah. So it's a half the sum of the parallel sides multiply by this perpendicular height C. Yeah. Now, the area of a kite is the same kind of business, and you wouldn't really have the area of a kite in CSEC, but it is on the syllabus. So you notice a kite is just two triangles. You could take this as the length A, and you could take this as the length B, and they would be perpendicular. And so a half A times B, it's very similar to a triangle. Yeah. And of course this is the formula for the area of a circle, and these formulas you just have to learn off, yeah? So the formula for the area of a circle is pi r squared, or pi times the radius squared, and the radius is what you'll be squaring, right? So these are the areas that you'll have to know. Let's take a look at them in a little bit more detail. So I have a square here, right? And let's just say that this square, of course, you know, a square has all equal sides. So let's just say they give us the length of one of the sides to be 10 centimeters. Yeah? So the area of a square that is side times side, right? So I know that this side is 10 centimeters, and this side would also be 10 centimeters because it's a square, right? So that'll be 10 times 10, which will be 100 centimeters squared. Now please notice the unit for area. No matter what shape you're dealing with, the unit for area will always have a square, right? So please make sure you always include centimeters squared, or if it's in meters, it'll be meters squared, or if it's in millimeters, you know, it'll be millimeters squared. So whatever the area is, the area will always be a square, right? In terms of to the power of 2, yeah? Now that is the area of a square. Now let's check the area of a rectangle, right? We have this rectangle here, and let's just say that this was 10 centimeters and this side was 5 centimeters. Well, then the area of the rectangle, that would be equal to side times side, or the length, which is the longer side, times the breadth, which is the shorter side, which will be 10 times 5. So whatever you want to call it, whether it's side times side or you want to call it length times breadth, it'll just be that you're multiplying one side times the other side. So this will be 50 centimeters squared, right? Remember, the unit will always be to the power of 2 for area, yeah? Now, if we are talking about a triangle, the most common type of triangle that we will find in CSEC math would be the right angle triangle. The right angle triangle we have to deal with in many different mathematics topics, as I said, including Pythagoras theorem and coordinate geometry. We all have to deal with the right angle triangle. It's a triangle we need to know very, very well. And the area of a triangle in general, so the area of a triangle is a half base times perpendicular height. Now the good thing about right angle triangles is that this height is already perpendicular at 90 degrees, so we don't really have to worry about it, right? So let's just say this base was 10 and this height was 5 centimeters, or let's just use millimeters for this example. Millimeters, oops, let me just, 5 millimeters and 10 millimeters for this side here, for the base, right? So then the area of the triangle would be a half the base, which is 10 millimeters, times the height, which is 5 millimeters. So that's 10 times 5 is 50 divided by 2, which is 25 millimeters. And because we're talking about area, it is going to be squared, yeah? So not the 25 is squared, the actual unit millimeters will have a power of 2 on it, yeah? So please always remember the square in the unit. Now we have here another type of triangle. For purposes, this is a equilateral triangle. And let's just say they give us the base to be 10. Let's say meters this time. Yeah. And they would usually give you the perpendicular height. So this perpendicular height here, let's just call this 12 meters, right? So the area of this triangle is the same, a half base times the perpendicular height, which is a half the base, which is 10, times the perpendicular height, which is 12, and that would be 12 times 10, which is 120 divided by 2, which will be 60 meters squared. Yeah. So at the end of the day, to find area, all we really have to do is learn these formulas off. And once we learn these formulas and we know how to apply them, then it's just a matter of identifying your sides and putting it into the formula. Yeah. Now, of course, we have another very special type of shape here. So, of course, we have another very special type of shape here. And this is essentially the circle, right? Now, the area of a circle and that's the symbol for a circle, is this formula pi by r squared. So the r is what is squared here. Yeah. So what we have to do is we have to, first of all, they have to tell us what r is. So sometimes they will give us r, and let's just say in this case r is, I don't know, 5 centimeters. Yeah. So the area of this circle would be pi times 5 squared, right? So what is the square? A square is when you multiply something by itself. So pi times 5 multiplied by itself, right? So that is pi times 25, which is 78.5, and the unit would be centimeters squared, right? So you can see here that even the area of a circle is just a matter of learning off this formula, pi r squared, and applying it. Yeah. Right, so sometimes we need to find out what is the area of a sector of a circle, which would just be this area over here, right? The area of this piece of the circle, bounded by 2 radius from the center, right? Now, we have to remember that there are a total of 360 degrees for a full circle. Yeah. So we need to know what is the angle here. And let's just say this angle is 90 degrees, right? So we need to find out what portion of the entire circle is this entire angle here. So if we find out the portion, that would be the 90-degree portion all over the 360 degrees, the full 360 degrees. And that means that it would be 1/4, right? So that means that this sector is 1/4 of the entire circle. So therefore, if I wanted to find the area of just this sector alone, the area of this sector would be 1/4 the area of the entire circle. Yeah. So I would find the area of the circle, which would be pi r squared, and let's just say they gave r to be 1 centimeter, right? So the area of the circle would be pi times 1 squared, and we all know 1 squared is just 1, so it would just be pi times 1, which would be equal to 3.14 centimeters squared. Yeah, so this is the area of the full circle, 3.14 centimeters squared. Therefore, the area of the sector, and remember this sector is only a quarter of the full circle. So it would be, the area of the sector would be a quarter of the full area. So a quarter multiplied by the full area, and that would be 0.785 centimeters squared. So when it comes to the area of a sector of a circle, they would give you the angle of the sector. You would need the angle, so they would give you the angle, and you use this angle to find out what fraction is that sector out of the entire circle. Yeah, and once you find out the fraction of that sector from the entire circle, like in this case, the sector is a quarter of the whole circle. So therefore, you would just, if you wanted the area of the sector, it would be a quarter the area of the full circle. They could give us a compound shape with polygons and circles, and we would need to find the area of this entire thing. So we would need to use reasoning, right? We see here that they give us this length to be 7 centimeters, and they give us this length to be 5 centimeters, right? And we have to understand that this length here, the 5 centimeters, would be pretty much equal to this length here. This would be 5 centimeters. So therefore, the diameter of this circle would be 5 centimeters, and therefore we could reason that the radius would be a half of 5 centimeters, which is 2.5 centimeters. So from the center of the circle, this radius here is 2.5 centimeters. Yeah, and we would have to reason that out. We would have to use our knowledge to know that this distance looks to be the same as this distance. So I could use this 5 as the diameter of the circle and therefore find my radius, right? So once I have these things, I could see that, all right, we have a rectangle here, and then we have a circle, well, a semicircle basically on this side here, and the rectangle over here, right? So what we would need to do is find the area of the rectangle and then add it to the area of the semicircle, yeah? So the area of the rectangle is pretty simple. That is just one side times the other side, and that would be 35 centimeters. Yeah, and now we have to find the area of the semicircle, right? The semicircle region here. We know the area of a circle, and that's a full circle, is equal to pi r squared. So the area of a full circle in this case would be pi by 2.5 squared, and the area would be approximately 19.6 centimeters squared. And so therefore the area of the semicircle would be a half of this. So the area of the semicircle would be 19.6 divided by 2, which is 9.8 centimeters squared. So now we have the area of the rectangle and we have the area of the semicircle. So therefore the total area would be the area of the rectangle, 35 centimeters squared, right? And that would add the 9.8 centimeters squared to give me 44.5 0.8 centimeters squared. So sometimes you could see that with area they could bring compound shapes. That's many different shapes put together. And so you would have to remember that, hey, this is not a difficult thing. I basically know basic shapes, and whatever compound shape they give you would be a combination of just your basic shapes. So you have to use the knowledge of the basic shapes to find these more complicated shapes. And it's really not that difficult once you know your basic formulas for areas and perimeter. So that's basically it for the area part of this lesson. And what is going to happen is that I'll post the video on Edmodo, and in the comments to the video I'm going to leave some worksheets for you guys to do. So feel free to do those worksheets and get some practice in.